start going up real fast between 70 and 73 because they got the proton working finally. So now they've got this big heavy lift rocket in comparative terms. So they can send their heavy spacecraft out. So their launch rate's going way up. Unfortunately, their success rate's staying right at about 10%. The American launch rate, you can see here, this is where we made the decision to go shuttle only. So we're no longer going to give you Titans and Deltas to launch your unmanned craft. You have to fly it on the shuttle. And those of you who, are you serious? Oh God, I got to speed up. Okay, I got to move along here. Okay, Mars 5M. This is a planned Soviet flight that never made it off the ground. It was going to use the N1 rocket over there. Most of you know that story. It was very good at exploding, not very good at flying. They tried it 4 times and never did make it. This was going to be a 20,000-pound craft, and it had a, there was 2 of them, one had a rover and one had a sample return. So here, about the same time as Viking, they're planning sample return, which is pretty ambitious. Never flew. That's what happens when you launch an N1, unfortunately. You know, when you got a rocket with 30 engines on the bottom, it's a tough thing to sync up, and it doesn't usually work. Okay, Viking flight configuration. I've got to speed up a little bit. I just put this in as I wanted to, I want to say salute to the departed Dr. Sagan, and 2, I wanted to see the size of the thing. This is what they at JPL call BDL, a big dumb lander. Big, heavy, went into orbit. We don't do that anymore. We just fly straight in the atmosphere and land. Back then they had the ability to go into orbit and brake and stop and look down and say, oh my God, there's a lot more craters there than we thought. Let's change the landing zone, which is exactly what they did with Viking. And so once this thing is heading down, it's just going to land where it's going to land. All it knows is how far the ground is. If there's a crater, too bad. Big rock, too bad. But it was very successful. I was at Ramo Auditorium in Caltech. Not invited, I snuck in. I was about 16, I think. This is the first picture that came back. There's a lot of argument about what are we going to see? We're going to look at the horizon, right? Well, no. The engineer said, I want to see the footpad and know that it's planted. But it was still damned exciting when it came in. That's the first panorama picture. Then they started doing color. This is the picture they gave out the first day the color picture came back to the press. There's a lot of pressure to get it out right now. And when NASA gets that kind of PR pressure, they got to respond. Then the next day the press came back and they got this picture. And they said, well, what's this? So, well, we corrected the colors. We were in a little bit of a hurry for the first one. We didn't get the colors right. To which some reporter, many of you know reporters, you know that we're not always the most polite people, stood up and said, what's it going to be tomorrow? Green. But, you know, it was an exciting thing. So these are not the highest resolution, but this is the first look we got at the surface of Mars. And we're able to see some of what's going on. I apologize, I got to get through some of this in a hurry. That's the Life Science Lab. Amazing achievement, size of a small dishwasher, 4 very sophisticated experiments. Did they not find life? That's an argument that could take another hour on its own. Probably not, but some recent research done by Chris McKay up at NASA Ames has shown that you can get the kind of results that they got on that with microbes in the soil with perchlorate. So that book has been reopened. This is the entirety up till the rovers of Mars that we had a chance to look at for life. So there are parts of the Earth you can land on and only scoop a radius about 12 feet and probably not find a whole lot either. You'll find some microbes, but the point is that the sample universe is very small. The orbiters, meanwhile, were up doing their thing, returned some wonderful stuff, and of course, oh, this is the famous Mars Smiley crater, by the way, one of them, which I'm sure conspiracists have been talking about too. Then we don't do anything for 20 years on the surface. Morning fog. So Pathfinder comes along, I'm sure you all remember that. Now we're up to an Isdc 85 processor with 512K of RAM and a little bit of flash memory. Went about 300 feet, lasted 90 days. It was only supposed to last 2 weeks. And was able to do some good science on the rocks. Took a long time, but it managed to pull it off. Let me get to the good stuff. MER, bigger, heavier, more capable, as you know, still going. One of them, Spirit, lasted about 5 years and then finally cashed in the winter because it just couldn't go on. Opportunity's still running. They're getting a little trouble with one of the wheels, and some of the computer memory, but it's still doing its work. And it's now gone, well, that's Victoria Crater. It's now gone up to Endeavour Crater, and it's still operating up there. This one ran off of basically a Macintosh PowerPC chip of 30 megahertz. These guys know how to program like nobody's business. This is just a quick look at how they explored one of the craters. You go around and around and around the edge, sniffing, looking, until finally you see a place where you can go in, which is Duck Bay. They drove down inside, got stuck around here briefly, turned around, came back out, went off to Endeavor. It's now done almost 23 miles. Finally broke the Unicod record. And this is the kind of stuff I look at. Why do you want to go in a crater? It's dangerous, it's risky, you might get stuck. But thank you, Mother Nature, you just did a big drill hole for us, and we're able to see incredible amounts of geologic history. So you're able to look at Cape Verde, and you got millions of years of stratification here that you can look at, and that's very exciting. And since we're following the water, that's a good thing, yeah. Okay. First meteorite found on another planet was by that. The infamous blueberries, these are little concretions of hematite, but it's yet again, you know, you keep hearing, oh, we see more evidence of water, and it's like, well, we get it already. There's a lot of water there. But you want to know if it's standing, is it flowing, is it an ocean, is it a lake, does it rain? And that's why they keep getting so excited about the evidence of water. And now Curiosity landed about, what, 7 months ago now? This is just a comparison of, go back. That's Pathfinder. Cute, isn't it? That's the MER, and that's Curiosity. If you ever get a chance to see one of these mock-ups at a museum, they're fantastic. They're huge. This is just a man for comparison. This is Gale Crater. That's the landing ellipse, smallest ever. You can't land on airbags and bounce to a landing and be within this couple of kilometers box here. So that's why they did that wacky sky crane. I'm sure a lot of you saw that and thought the same thing I did. What in God's name have you guys been drinking? But it worked. And as it turns out, when you're landing something that heavy, you can't put a rocket motor on the bottom because it's going to roll off axis and tip and crash probably. And they didn't have any rocket engines they could use with that off the shelf. They had to basically reinvent the Viking engines to do it. That's why they did the, I know, that's why they did the sky crane. So I'm going to skip through this very quickly, just get us to the boreholes. That's the first pilot hole. That's the 5-centimeter one they dug. And as you know, even though there's a lot of confusion at JPL about how they're going to announce this, we didn't find organics. We think we found organics. We're not sure. We're going to check. So now they're moving on to the next drill hole, which is about 9 feet away. And if they confirm the results, then there are probably non-life related organic signatures on Mars, but time will tell. Last bit of trivia. This is one of the wheels. They're about this big, and they needed to be able to see their tracks and count rotations. So somebody got clever, cut these holes into Morse code, and it prints JPL on the sand, which I thought was one of the coolest things I had ever seen. They originally had it in script at JPL, and NASA said, no, be subtle. There's a story about the drill, but we'll have to go that another time. We've got Maven going up very soon. ExoMars going up in 26 and 2018, we hope. NASA was a part of that, but not now. And then, of course, because you're here, you know all about Inspiration Mars, the Dragon Mars flights, and hopefully we'll see that sign stuck on a rock sometime in the not-too-distant future. And I thank you, and I gotta go.
Thank you. Trying to get back on schedule. We're going to take a quick 5-minute break before the next session, and after that will be a student settlement design presentation. So we'll be back here at 11. Thank you.